Welcome back, students. In the previous parts, we have discussed about the Lewis dot structures, octet theory, and the formal charge concept, right? In this part, I'll be teaching the bond parameters, which are the parameters which determine the shape of the chemical molecules. So let's start. Our topic is bond parameters. Here you will see that what are the parameters whenever chemical bond is formed. Bond parameters. The first parameter is bond length. Bond length. It has been defined as equilibrium distance. Be careful here. Equilibrium distance between the nuclei of two bonded atoms in a molecule. So if I write here, suppose this is my A, this is my suppose B, they are covalently bonded, then my this distance, equilibrium distance, is the bond length. Bond length. What is the equilibrium distance? For example, if I try to find the covalent radii, so it will be covalent radii, it will be equal to half of this distance. Suppose this is R, half of R. So this is termed as my covalent radii. Bond length is the equilibrium distance between the nuclei of two bonded atoms. This is the bond length. And how we will measure such a small quantity? There are techniques like spectroscopy, X-ray diffraction, which helps in calculation of so small. They must be in picometers, right? They are in picometers, so they are that small. For that we use the technique spectroscopy and X-ray diffraction. Our next parameter is bond angle. What is bond angle? It is the angle between the orbitals which contains the bonding pair electrons around the central atom, or in a general way you can look at like this. For example, this is my A, this is my B, this is my C. So this angle is called your bond angle. Suppose this is theta. This angle is your bond angle. It is expressed in, obviously it will be expressed in degrees. Now what happens in covalent bond? The covalent radius, I told you that to calculate that you have to half the distance between the nuclei equilibrium distance, that is a bond length. So contribution from each atom you have to see. If you want to find the covalent radius, generally we take two similar atoms bonded covalently, and the van der Waals radius represents the oversize. There is another radius called van der Waals radius. Like for example, if I drawn here as this molecule, this is the half of the distance, this will give me my RC as covalent radius. Van der Waals radius, there is a difference between van der Waals radius and covalent radius. In case of van der Waals radius, they are not in a bonded situation. This is the main difference. How they will be? For example, if AB is my molecule, then there will be some another molecule AB here, and this nuclei distance, if I make them half, then this will be my RVB W, van der Waals radius, or just RW sometimes, van der Waals radius. So you must have understood the difference between covalent radius and van der Waals radius. Next parameter is bond enthalpy. Bond enthalpy. It is defined as the energy required to break 1 mole of bonds. For example, if H2 is there, then how much energy I need to break this bond if I take 1 mole of it, if I take 1 mole of it, how I will take 1 mole? I will take that much grams of, I will say, that much grams of that molecule. And to break that bond, the energy required is called the bond enthalpy. Of course, the unit will be kilojoule per mole. And you can see here with H2 molecules, if I provide the bond enthalpy, the energy delta HA required is H plus H. The required energy is 435.8 kilojoule per mole. Similarly, for oxygen, it is 498 kilojoule per mole. So it is the energy. For example, O is double bonded. So to break this double bond, what is the energy required? The energy required is 498 kilojoule per mole. That's it, the bond enthalpy. And of course, if my bond enthalpy is more, of course my bond is stronger in that molecule. In that molecules, my bond is stronger. Sometimes we take average bond enthalpy, and that is with the case of polyatomic molecules. See here, H2O. If I break the bond here, first H and OH, this is a suppose molecule H2O. Suppose this bond get break first, so that requires this much of energy. In order to break the second OH bond, this much energy we have to supply. So what is the average bond enthalpy? That is equal to this energy plus this energy divided by 2. That is your average bond enthalpy, that is equal to 464.5 kilojoule per mole. Next is your bond order. Bond order is the number of bonds between the molecules or atoms. I will better write it as atoms, not as molecules. Atoms, number of bonds between atoms in a molecule. For example, H2, if it will form the bond, I will have 1 bond, so its bond order is 1. In case of O2, I have this structure, I have 2. N2, I have 3. So this is the number of bonds between the atoms in a molecule, and it is 3 in case of nitrogen, 2 in case of oxygen, and 1 in case of hydrogen. And N2 is the one which has highest bond enthalpy for diatomic molecules. Of course, the number of bonds is 3, so it needs higher energy also to break this much amount of bonds. And one point must be clear to all you guys, that isoelectronic molecules have identical bond orders. For example, if someone asks you to calculate what is the bond order of CO, then how you will calculate? Will you form bonds and do all this? There is no need. You just have to think that what is the isoelectronic species of CO with respect to a diatomic molecule. It is similar to N2. Both are having 14 electrons. N2, you know, have bond order 3. So CO is also having the bond at order 3. It is general correlation useful for understanding the stabilities of molecules, because when bond order increases, okay, suppose my bond order increases, this will increase my bond enthalpy, but my bond length will decrease. My bond length will decrease because my equilibrium distance will come even more closer. That is the reason. So this is what for bond parameters as considered. If you have any doubts in this chapter, you can log on to www.askIITians.com. There you can go to our discussion board and you can post your question by choosing your category. You have to select your category and you can post your question here. We experts at Ask IITians will answer to your question or doubts within 24 to 48 hours. In this part, we have covered about the bond parameters which are affecting the shape of chemical molecules like bond length, bond order, bond enthalpy and bond angle. In the next part, I'll be teaching you about the resonance structures of the chemical molecules. Stay tuned with that.